going on, y'all? This is OXDF looking at Advent of Code Day 3. Let's go ahead and dive in. Submarine, blah, 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 diagnostic report. Use these binary numbers to generate two binary numbers called gamma and epsilon. It's always worth, if you're trying to speed do this, it's always worth looking at the things they put in this kind of bold here. Anyway, each bit can be determined by finding the most common bit in the corresponding position of all the numbers in the report. For example, giving this report, considering only the first bit, there are 5 zeros and 7 ones. 1, 2, 3, 4, 5. Okay, yeah. Since the most common bit is 1, the first gamma bit is 0. The most common bit of the second is 0. So the most common bit of the third, blah, blah, blah. The gamma rate is that. The epsilon rate is calculated a similar way. Rather than use the most common, use the least common. The epsilon rate, blah, blah, blah. Okay. And then multiply them together. Okay, so I need to, okay. So right off the bat, I can say I only need to figure out one of these, and the other one is the binary not of the first one, right? So because it's either going to be, if it's 1 here, it's going to be 0 here. So I can just worry about finding one of them. Let's grab this, come over here and do vim. What would I call it? Oops, not 2. Let's make it 3. Paste that in. And we'll need to get the puzzle out. Where's the puzzle? Put here. 3. There we go. All right, so let's write some Python. Say 03.py. Put our shebang. This is actually really cool because we can take advantage of something we talked about yesterday, which is using the star to expand an unknown number of variables in space. So, okay, I'll not get ahead of myself here. Let's open up the file, sys.rv1, read as f, and then we'll just do lines equals f.read lines. And in fact, one thing I'm gonna go ahead here and do a list map. Oops, str dot strip that. And so what this does, map, I think I talked about this before, but map takes a function, so the string function strip, and applies it to each item in a list. So it's going to take each of these lines and strip the new line off the end. Things like map and zip, if you're going to just loop over them, that's once. Then you don't need the list here. But the way it does some optimizations in memory so that it just stores them as a generator object. But if you just need the whole list to use over and over again, you you pass it to the list function, and then that's what you got here. So since I don't know how I'm going to use it, I'm going to go ahead and keep it in a list and not as a map. Okay, so now I've got the lines. What I want to do here, and this is, we'll go ahead and actually Python 3 minus I day 03. It helps if I give it input. 03 example. Cool. So I've got lines. That looks good. And this is what I want to be able to do. This is where zip is going to be awesome. What I want to do is take the first of each of these and then take the second of each of these, etc. And that's exactly what zip does. So, if you remember, if I take zip, if I pass in like zip of that, and here's an example where I need a list object. If I'm going to show it, look, it takes the first of each of those and the second of each of those. And if I put in, a third object, I'm getting 3, etc. So what I can do, if I do, what I'm going to do here is, we talked about this yesterday, but if I put a star here, what it's going to do is it's basically going to take the array lines or the list lines, and it's going to remove it from the list and create n, in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 individual inputs to the zip function. And I'm going to get, it's kind of hard to see, but you can see here's the first bit, here's the second bit, etc. So that's kind of cool. Now I've got them all grouped together. So I need to figure out, okay, what is the most common in each of these? Let's see. There's probably a way to do it without this, but this is where I really like from collections import counter. Collections. And so now what I can do is I can come up here and I can do counter x for x in that. Now I've got a list comprehension where we're going to loop over each of these results. So, it's going to be one per bit. And we're going to create a counter object, which is just going to tell me how many of each type there are. And so you can see for each bit, I now have, for the first bit, there are 7 ones and 5 zeros. We can go back and check. Is that what it said? And then considering the example, this is the most common bit is 1. Oh, yeah, there are 5 zeros and 7 ones. Yep, so we're on a good track here. And so now, what I don't remember exactly is, here, so let's save this as a variable. Let's do dir of a0. What I'm looking for is what's the function that gives me just the most common one? Most common? Seems like a promising function. Give me multiple. So most common just one. There we go. And I don't get returned it as a list, so I want to get rid of that. And then it's giving me the value and the count, so I just want the count, so it's going to look like that. So what I really want here is counter.most common 1 0 0. Sweet. And I can do a dot dot join there, and I can do an int comma 2 for binary, and I get 22, which is what I was looking for, and that's the gamma. How do I do a binary? I don't remember how to do a binary not in Python. Bitwise operators. Oh, is she just gonna be putting the squiggly in front of it? It is. Let's see if that works. No, that gives me negative 23. That's not what I wanted. Interesting. Positive? How am I bitwise not operator in Python? So the problem with using the squiggly is it works with signed integers. Yeah, okay. For 4-bit, you should just subtract it from. Oh, okay, that'll work. So I need to know the length of the. Oh, this might be kind of ugly, but okay. So let's say we'll do the length of lines 0. It's gonna be like 5 times 1. This is ugly, but we're going with it. Minus 22, so give me 9. It is. Okay, I guess that works. So I'll come here and do gamma equals, let's see, this right here. I don't remember what the other one was called. Epsilon, maybe? Let's see. The most common, the gamma, the epsilon. Come back here, and we can do epsilon equals int len lines 0 times that homework 2 minus gamma. Print. See if this worked. Part 1. Oops, I don't know why I put the squiggly there. Squiggly gamma times epsilon. Ooh, didn't mean to do that. That look right? Let's run it. Oh, I have to do the imports that I did up there as well. From collections import counter. 198. What was the answer according to my puzzle input? 198. Sweet. Let's try the real input. 03.input. See if we can get it here. Sweet, we nailed it. Okay, continue to part 2. Now you need to vary the life support rating, which can be determined by multiplying the oxygen generating by the C2 scrubber rating. Okay. Rating are values that can be found in your diagnostic report. Finding them is tricky part. Those values are located using similar process that involves filtering out values until only one remains. Okay. Before searching for either rating value, start with the full list of binary numbers from your diagnostic report and consider just the first bit of those numbers. Then, keep only the numbers selected by the bit criteria for the type rating value. Discard the numbers that do not match. If you have only one number left, stop the rating value. Otherwise, repeat the process, considering the next bit. Okay. The bit criteria depends on which rating. Okay, to find the oxygen rating, determine the most common value in the current position. Keep only numbers with the bit in that position. If they're equally common, keep a 1 in position being considered. Find the CO2 scrubbing rating, determine the least common value. Keep only numbers. So they're really pushing me to use a loop here, not like a zip. I guess that'll be fine for this section. So I've already got, the good news is I've already got from my epsilon and I forgot what the letters were. My gamma and epsilon ratings. I've got the most common value at each position. That's good. Okay, so keep only the 7 numbers of the one in the first section. Second bit. There are more. Oh, but now it changes. There's only 7 remaining numbers, so I don't want to apply. I need to do my filter. I need to look at the first bit, filter, apply, and move from there. So that is trickier. Okay. I'm gonna stop doing it like all one-liney, list comprehension, zippy. I'm gonna have to do like a real loop here. Probably. Okay. If they're equal, we keep 1. All right, let's think about this. This is a little bit trickier. Let's come up here. For line, there might be an elegant way to do it. Maybe we'll come back at the end if there is, but let's start by just writing it out the long way, because that's certainly the fastest way to look at it and the easiest way to think about it. If the problem's not like obvious right off the start. So I don't actually want to do line and lines. What I want to do is I'm gonna do it's the cardinal sin of well, we'll do this. For I comma b in enumerate, I'm not sure this is actually any better, but lines 0. So I'm getting the first line, I'm getting the I that goes with it. So now I'm going to have this I. And so I can take, I can get, I don't even need that because I'm going to get it down here. So B for B in lines, no, let's see. L for L in lines. So I'm going to get each line, and for each line, I'm going to get the ith value, like that. And then I wonder the best way to do this is. I almost wonder if the best way to do this is a recursive function, which sounds crazy, but let's try it because this feels very recursive to me. Because we don't really know how many bits we're going to be dealing with, right? Or how many steps we're going to have to take. We'll call this def filter, and it's going to take in some list. If we can't call list, that's a function. We'll call L, some list L, and it's going to take in a most or least. We'll call it most equals true. Okay, so now I have a list, and what I'm going to do, a bit position. Items. nums position. Okay, so what I'm going to do is I have some list of numbers, and I'm going to loop over. I'm going to look at all the. Okay, so for first I need to get the most common, so I'll do that just like I did before. Um, so I'm going to do a counter on. Let's see. This is going to be B for B in nums. Num sub position for num in nums. So what I'm doing here is I'm getting the bit I'm looking at. So when the first time I call this, it's going to be position 0. I'm going to get just that. And then I'm going to make a counter here, just like I did before. And I'm going to get most common 1, 0, 0. So that should give me the most common bit for that position. And then I can do if make this least oh, hey, I got an idea. Okay, sorry, I'm like thinking out loud here, and this is so remember up here, let's go, how I called most common and it returned both the two most common things. So what I'll do here is I'll do least equals true, then it would be, that's basically a 1. This is hacky, but we can do most common, get both of them. Then do I want the first object or the second object? What I want is least. Because if least is true, that'll be a 1, and it'll give me this pair right here. And if least is false, it'll be a 0, and it'll give me this pair right here. So that should give me the most the filter. Yeah, it's not really the most common anymore. It's the, what is it? Common. Let's call it common. Oops. So now that I know the answer for that position, I can say n nums for num in nums if num sub position equals common. And that'll give me the new list. New nums equals if when new nums equals 1 or position equals len nums minus 1, return. What do I do if there's only, I guess it doesn't give me, this is an edge case, it's not dealt with. So maybe I can assume, I don't think they give me instructions on that. Let's not include that yet, because if I do hit that case, I want to know about it. If len new nums equals 1, return new nums. Yep, okay, new nums 0. Else, I guess I don't need the else. Return filter new nums position plus 1 least. Okay, so what this is going to do is if the new nums list is 1, great, it's going to just return that value, was what it asked for. If the new list is not 1, it's going to pass the new list in with the move position forward 1 and pass the new list into the same function. So this is the recursive part. And it's going to then run that new list through the same filter on the next position, and if it gets a length, it'll return it, which will then come back here and return again, or it'll pass it into another level of depth. So to test this, what are we going to do? So we're going to do, we're going to get interactive again, because that's how I roll here. Day 3 example interactive. Okay, so if I call filter on lines, I believe it was. Of course, I need position 0 to start with. And it returns to me that. What am I going to get out of this? Should be my oxygen let's see, by default, least was true. So let's false. So by default, least, what's my example here? My number, oxygen generating is 101110. Oh, 111. Oh, I'm close, but I'm not quite right. Oh, I bet you I'm having a case where if my counter is let's see. So according to this, it's saying the most common number is 100110. And the most common number here was 101110. So I'm doing a good job there. What I'm not necessarily doing a good job is getting, so that's right. Let's get rid of that. Print new nums. Okay, so then there's 1, 2, 3, 4, 5, 6, 7 left. Right? Okay, so I get down to the correct last two. In the fifth position, there's an equal number of there, and so that's my problem right there. Is my counter here, my common is, I get down to this last one where there's only two left. And I'm looking at this last bit, 0 and 1, and they're equal. And so it's sorting them alphabetically. And I need to sort them anti-alphabetic. Like, I want the tie to break to 1, but because of the way collections was working, it's not. I wonder if I can just do a sort. Let's see. Try this. That. Ooh, didn't do that. Undo. What is going on in my terminal? That's weird. I'm not exactly sure what happened there, but I think we're okay. Run again, make sure. Okay, I think we're back. There was a bunch of U's to undo and see if, okay, so we're back to a working state here. Okay. So what I was going to try to test here is, can I paste that in? No, that's not what I wanted. There we go, it's a paste. Okay, there's my counter for most common. What I really want to do before I take this 0 is, which 0 am I looking at here? That one's fine. So but that one's too late. So I need here. I need to sort this by sorted, comma, key equals lambda x. I want x sub 0 sub 0, comma, reverse equals true. And I need to close sorted. And this, I'll explain what I'm doing if this works. So it should be the same there. So basically what I'm doing is I'm taking this counter object here, which looks like that. And I'm saying before I want to sort this based on this object here, I want to do it in reverse because otherwise 0 will come first to get 1 first. Oh, that's not going to work. Need to do, I only want that sorting in the case of a tie. So I'm going to do x sub 0 sub 0 sub 1, comma. I need a tuple like that. Let's try this again. I think I'm messing something up. What I'm going to do is I'm going to come up here. I'm going to go ahead and call res equals filter lines 0 false. I'm going to put a break right here. So that's line 16. So we're going to mpdb minus c break 16 minus cc to run it, and we'll run. Okay, we're here. What we want to do is we want to take this, and before we get least or most, we want to sort. It does this weird thing where inside loops, it doesn't work well, but I know I'm looking at position 0 right now, so I'm just going to deal with that. Okay, so that's what I want. I want to sort this. I'm going to do sorted. I'm going to do key equals lambda, so a really short function that takes in x, so x will be each of these values, and then it's going to return things in the way I want them sorted. So I'm going to return a tuple. I'm going to do x sub 1, that's the first thing I want to sort by, and then x sub 0. So if x sub 1 is the same, so if this is, and these two are the same, then it's going to sort based on that. And then I'm going to do reverse. Oh, I can't do reverse equals true. Okay, don't want reverse equals true, but I can do negative. I guess I can put a negative here and then do reverse equals true. Did that work? No. No, it did. No. That did work, interestingly. I wonder why that worked. I would have expected that negative there to really throw things off. But it's not. Okay, so I want that looks good. No, it's still gonna fail. Reverse equals true. And I want to get rid of the negative. I think, I don't have a case in front of me, but I think if, well, let's continue, because let's get to that case we're going to get to in a minute. Continue a couple times. Nums. Why is nums not defined? I hate, inside of, PDB does get kind of weird inside of these things. Because nums is defined, it's going to work. Where's my position? 0 still. Ugh, this is where PDB and a recursive function is kind of a mess. But I think this is going to work. And let me go up here and show you what this is going to do. So let's take this. We're going to take this here, and we're going to, well, so we can just write sorted. That's most common, comma, key equals lambda x sub 1, comma, x sub 0, comma, reverse equals true. Let's see if this works, and then I'll try to explain it if it does. Part 1, when I didn't print, what is res? It looked at the right. So I have these counter objects here, and my problem is I need to rearrange a little bit in the case that right now it's sorted by most common, which is what I want. But in the case where the two most common are the same, then it puts the 0 first, and I want the 1 first. And so I could do I could just capture this counter and do a check if they're the same, and then return 1, and otherwise do the same thing I've been doing. But for some reason, my need to do this in one unreadable compact line, I'm going to sort it. I'm going to sort those things. I'm going to sort those items first the way they're already sorted by by the count. So that's this right here. So basically, this is what gets passed into the lambda, each of these objects. And first, I'm going to sort based on this. And I guess sorted actually for numbers works low to high. Didn't know, that was not my intuition, but that's clearly what I saw. And then I'm going to sort by this one. And in both cases, and this is alphabetical, I guess low to high as well. So in both cases, I want to flip it. So that's why I just do reverse true. And now with this newly sorted list, I can get least, which will tell me, it'll get whichever one, depending on what I passed in, least or the most, and then it'll get the first item, which is the result itself. And that will give me, then I can do the filter here and the same check I'd been doing before. So that worked. So let's see. So what we're going to do here is we're going to do an int, comma 2, and we're going to call this O2. and we'll do CO2 equals, this one's not going to be just not like the previous one. So yank paste, YYP to paste it, and we'll do CO2, and we'll just change this to true. Let's see how that works. O2, 23, CO2 is 10. What are my answers here? 23 and 10, looking good. We're going to multiply them together to get 230. So we'll do print, insert print f string part 2, and that will be O2 times CO2, like that. And 230. Get rid of the I, and now we can do O3-in and see. I'm kind of surprised if this works, but we spent enough time on it, so it worked. Awesome. I think people, at the end of the day, this is a speed challenge, and I think probably you go look at the people who compete, who stay up, to jump on right at midnight and try to be the top 100 or whatever, top 10. I'm going to guess this was just more complicated than they want to approach it, and that they're probably just going to do a simple loop over. They're going to count. They're going to look over the bits. They're going to do something like for I in range len lines 0, and they're going to then use that loop. They're going to make a lot of variables and keep counters, and they're just going to track things that way. And it's one of those, like, it's not Pythonic, but it certainly is. When you're going for speed, a lot of times you just want the simplest laid out thing where you're not making errors and you're not having to drop into the debugger. I like to try to play around with like trying to use kind of these interesting Python concepts. So again, I'm not even sure this is better. There's probably a happy medium in the middle. Like this right here is completely unreadable. So if you weren't watching me write this, if I just like check this in at my company, the next person coming along trying to read this would be just like, what on earth was he doing here? So it's not great, but it's certainly to me at least, I find it really interesting to figure out how to put these really complicated lines together that can do so much in one line, for example. So anyway, gonna call it here. Thank you so much for sticking around to the end. I really appreciate it, and I will talk to you tomorrow.